Hey everyone, here with another video on CalcPlot3D. This time we are going to look at how we can examine volumes underneath surfaces, and in particular look at like these double Riemann sums to approximate volumes. So even though we're dealing with surfaces, we're not going to add a function or implicit surface. We are going to go to region, click on that, and basically we're going to be able to see our 2D region over here on the left, and then we'll see the volume above that region and underneath our surface over here on the right. So I want to draw your attention to these two parts here. So basically you can define your 2D region, and I'm just going to start with a rectangle because that's really what we're dealing with when we're doing Riemann sums. So I'm going to let my y go from 0 to 2, x from -1 to 1. That sounds good to me. And this one already has the default, so you can also define what surface you want. So here we want the volume above the xy plane, z equals 0, and below our paraboloid or bowl shape, x squared plus y squared. So I'm going to hit enter. And this is kind of going off the screen, so I'm going to zoom out once. So here on the left, right, you can see the square or rectangular region that we have. So y goes from 0 to 2, x goes from -1 to 1. You can also see that here if I rotate and then look from above, right? So y goes from 0 to 2, x goes from -1 to 1. But we also see our bowl shape, and we have the volume above the xy plane, and specifically our region, and then below our bowl, right? So that's how we're defining this volume here. Now, if you want to see an approximation using rectangular prisms, right, do our Riemann sum, you can click Show Riemann Prisms. So it defaults to using 4 subintervals in both the x and y direction, so we're seeing 16 subrectangles. And here it says the volume of the region is about 6.5 cubic units. It also says it up here, which matters because if you click, then it disappears on this part of the screen, so you want to go up to the green bar. And so you can see all these 16 subrectangles, and that's a bit much for me right now, so I'm going to go down here. And so this is where it's defined. So this is the number of prisms in each direction. That's your number of subintervals. So if you want like 2 in each direction, so in that case, right, since these are both length 2, from -1 to 1 and 0 to 2, this means my delta x and delta y now are each 1. Then I get 4 subrectangles. And what's determining my height? Well, that's right here, height by, in this case, midpoint. I find it helpful to click on this last little box that says show points used for heights. So if you click on that, so first of all, notice that my volume went down for my approximation. So this is probably an underestimate, and we can see that even though the front parts of my subrectangles, or my rectangular prisms are above the surface, the back parts are below. And my bowl grows most quickly right here at the top, and so this is why we're seeing probably an underestimate. And this is about 6. But over here, you can even see, like, here are my midpoints. These are exactly the test points used. And if I rotate, you can see exactly how they are determining the height, right? So these are literally the z values when you plug in those midpoints, and that's giving me the height of my rectangular prism. So then if we go up to, let's see, 4, we got 6.5. Let's see what happens if we go up to 8. So 1, the picture gets a lot more complicated, but we also get 6.625. If you go up to like 12 a piece, then it gets really gross, and the grid over here is basically unrecognizable. And it looks like we're approaching something like 6 2/3 cubic units. That would be my guess for what the actual volume is, but that would require me to do a double integral, which I'm not going to do in this video. So that is basically everything that you can do with midpoint sums. And then I just want to quickly show you how you can use other sums. So you're basically not going to worry about the inner versus outer. That's just stuff you would use if you have a region other than a rectangular region, but we only deal with rectangles when we're doing Riemann sums. So really the only thing you'll ever click on is the height by, and you can do upper left, right? So this literally just gives you the upper left corner as your test point for each subrectangle. And you can see here, this is a very clear overestimate. All of these are towering above your surface, and we guess 12 cubic units. But again, if you end up with like 12 apiece, we're probably going to get pretty close to 6 2/3. Yeah, we're down to 7.37, so we're already getting close. And again, you can do basically any of the corners, upper left, right, lower left, right, and then the midpoint. So you got 5 different options, which are basically all the ones that we've done in class. So if you're doing Edfinity or working on practice problems, hopefully this can help you visualize and also check yourself, right? And see if you get the same volume that it is getting with the same test points. So hopefully you find this helpful, and that's all I've got. So thank you for watching.